In this video, I would be telling you about data structure part 1, and moving on to this, we would be discussing very important topic which usually comes in exam, that is tags, queues, singly and doubly linked list and circular lists. All these topics are very important from the point of view of the exam. So first of all, tags. Now what is tags? Tag is a linear data structure which follows a particular order in which the operations are performed. So basically it as we can say, when we go to a marriage, we see a lot of plates, right, in which we eat. So the plates are kept how, one above the other. So the plate which is kept first is the one which we take out the last. So it always follow the order is LIFO, last in first out. That means the last plate would be the one that would be used. The first place would be the last plate to be used, right? So that is LIFO, last in first out. So we usually take the last one and first one is kept at the very end. So there are many real life examples of stag. Consider an example of a plate stags over one another in the canteen or in a marriage or whatever way you like. The plate which is at the top is the first one to be removed. That is the plate which has been placed at the bottom most position remain in the stack for the longest period of time. So this is a diagram basically. In this it's showing the stack. There's an insertion and deletion happens on same end. So this is very important, that the push and pop. Actually in stack we always use the term push and pop. I was just checking the answer sheets of my students. What I noticed was they were confused between stacks and queues. In queue there is no push and pop. You will not say push and pop. The terms push and pop is only for stags. So push is for stag, that is for insertion, and pop is for deletion in stag only. So it always follow last and first out, and at the top of the stag everything is done at one end, right? Next comes the queue. So queue is a linear structure which follows a particular order in which the operations are performed. The order is first in first out, that is FIFO. A good example of a queue is any queue of customer, like queue when we go to buy a movie ticket. So the first person who goes to buy the movie ticket is the very first one to get that, right? So in a queue it is always first come first serve basis, right? So FIFO it follows. So there the insertion is at one end and the deletion is at the other end. So that is not on the same end as in stack. So that's the difference. So the difference between stack and queue is in removing, of course. In a stack, we remove the item at the most recently added. In queue, we remove the item that is least recently added. And the person who will take the movie ticket at the end, who will come at the end will get that ticket at the end, right? So queue is an abstract data structure somewhat similar to stack. So it is very important. Insert data. When you want to insert some data, that is known as NQ. And when you want to delete some data or remove some data, that is known as DQ. Fine. This is the diagram of queues. So there is a queue, there is insertion and deletion happens on different end. This is NQ is insertion and DQ is deletion. And front and rear are the terms used for. Rear is for insertion and front is for deletion. So at the front end the deletion happens and at the rear end the insertion happens. So in queue you will be using front and rear. Fine. Now this is again an example as a one way road. You can see this is example of queue, a real life example. Now this is NQ, DQ. These are some of the operations of queue, that is peak, is full, is empty. These are the steps how to first of all, these are the steps for inserting something in a queue. First of all, you check whether the queue is full or not, because if you want to insert something in already full condition, it won't be getting inserted. So you have to check whether it's full or not. So if it's full, then you say overflow error and you exit. If the queue is not full, then you increment the rear pointer. Fine, because rear only you insert it at the rear end, as we have seen the diagram. So the next is empty space and add data structure to the queue location where the rear is pointing and then return success. So it's been added, step 5. This is how it's done. D element is added and the rear position changes from C to D, before and after. Now comes another very important topic, that is linked list. So there is first of all the singly linked list. Now what is a linked list? Linked list is just like a train. You have boxes. So this box is known as node. So this is in the diagram below. You can see that there is a head which points to the starting of a node. Then there in a singly linked list there are two things, one is data and the other is next. So next always points to the address of the other node. So and the last node contains the null address. So null is there. So a linked list is a linear data structure in which the elements are not stored at continuous memory location, and the to the memory locations is not continuous because it's pointing to the address. Next is pointing to the address of the other node. So in simple words, a linked list consists of nodes where each node contains a data field as a reference, a link to the next node in the list. Fine. So this is how they have said. One is a link part, next, and linked list. So you can read this out. Coming to the linked list representation, in the diagram you can see below, there is a head which is starting a link. The whole this thing is known as node. There contains data items. There is a next which points to the next address of the node. So there is again a data item, then next. So this is all it's written if you see in the theoretical part here. And the end node contains the null address. The next will contain. Now they are the types of linked list. So there is simple linked list, doubly linked list, circular linked list. So basically single linked list we have already discussed. Doubly means where the traversing is from both the sides. That means the you can go from left to right also and from right to left also. So that is the case of doubly linked list, in which the the pointers are at both the next position. There is a pre for previous address of the node carrying, and there is a next as in singly there is pointing to the next node. Circular, it is there is no null pointer. The last node carry the address of the first node, so it becomes a circular linked list. These are the operations of linked list, like insertion, deletion, display, search, and delete. You can read it out. See the diagram there. This shows there is a head. This is a doubly linked list in which you can see the first one is carrying the null, as well as it's a pre is for previous pointing to the node. There is a next, again there is a pre, so it can move back also. The second node has the address of the first node, the third node has the address of the second as well as of the fourth. So in singly we were having only one way traversing, as one side one way road, we have that car diagram we have seen. But in doubly it is a like 2-lane road in which there can be both side, it can move from left to right as well from right to left. So this is the coding part. If we say in this, they say this is how we in codes we create a node, like struct node, curly braces on, int data item is always there in a node. So struct node pointer next, it is pointer to the next node. In doubly linked list they are talking about. And struct node pointer previous, for previous node pointer it is showing, curly braces close and a semicolon. This is how a node is inserted or a node is created in doubly linked list. Fine, with this help diagram. So this is advantage of doubly linked list over singly linked list. So this you can read it out. Of course it is better since we can traverse both ways. Now comes the last type of list, that is circular linked list. You can see it is in circular. The last nodes carry the address of the first node. So this is the circular linked list, as you can see in the diagram. This is how it's showing. So the pre is carrying the last address, and the next of the last is carrying the first node address. Thank you. I hope you understand this video. Thank you and have a nice day. Please subscribe my channel. Thank you.